Okay, so we're doing another question on the topic numerical solutions. Okay, part one says, by sketching a suitable pair of graph, show that cosecant x equals half x plus 1, where x is in radians, has a root in the interval 0 to pi by 2. Okay, so we will be sketching two curves on the same graph, the curve for this cosecant x and the straight line for half x plus 1. Okay, so I'm going to make a y-axis and x-axis. Now I need cosecant x graph. So I know cosecant x is reciprocal of sine x, and the graph for sine x looks like this from 0 to 2 pi. This is 2 pi, this would be pi, and this is just pi. So sorry, pi by 2. So the domain here is from 0 to pi by 2. So I need its reciprocal graph within this region. So that would be, this is 0, 0 becomes infinity, and this is 1, 1 stays 1. So the graph looks something like this. It comes down from positive infinity and comes down till 1. Okay, so this is the graph that you plot here. This would be 1, and this would be pi by 2. We don't need rest of the graph. The rest of the graph, by the way, goes like this, but we don't need the rest of it. Okay, and now, acha, make sure that this graph goes pretty close to the y-axis, but without touching, because the y-axis is supposed to be the asymptote. Okay. Now on the same grid, we need to sketch the graph for half x plus 1. So for y equals half x plus 1, I know that the y-intercept is 1. So 1 is already shown. I need another value on this grid. So what I'll do, I will replace the x with pi by 2. And let me check what does this give us. So 0.5 times pi by 2 plus 1 is 1.78. So if that's 1, then this is going to be 2, and 1.78 would be somewhere over here. So the line would go something like this. So you make a line like this. Okay. Now, how do we show that this has a root in this interval? We show 0 here. We show pi by 2 here. Pi by 2 is already shown. You make a small cross on the point of intersection, and you write the concluding statement that one point of intersection shows there is one root between 0 and pi by 2. One point of intersection, hence one root between 0 to pi by 2. Or you may write it in the form of inequality. Yeah, it's better to write it in the form of inequality. 0 less than x less than pi by 2. Okay, the next part says, verify by calculation that this root lies between 0.5 and 1. So what we do now, we bring everything to the same side. Cosecant x minus half x minus 1. So you write fx equals cosecant x minus half x minus 1. In fact, we're going to write 1 over sine x because there's no cosecant function in the calculator. And now we're going to enter f 0.5 and find f1 and show that there's a change of sign. Make sure the calculator is in radians. So for 0.5, you should get 0.835 it. And for 1, you should get negative 0.3116. And you write greater than 0 with this, less than 0 with this, and then write the concluding statement that change in sign shows that the root lies between 0.5 and 1. Change in sign shows root lies between 0.5 and 1. Next part, show that this root also satisfies this equation. So what you'll have to do, you'll have to either rearrange this and show that you get this, or rearrange this and show that you get that. So choose any side. I think I'll start with the equation given in part 4 and rearrange it and change it into equation in part 1. But you could always go the other way around as well. Okay, so send sign to the other sign inverse to the other side, sin x equals 2 over x plus 2. Okay, in here they've written cosecant x, so I'm going to write changes into 1 over cosecant x equals 2 upon x plus 2, and swap the places of both the fractions, or take reciprocal of both the fraction, split the denominator, half x or x over 2 plus 1 is equals to cosecant x, so shown. Next part is use the iterative formula with an initial value of x1 equals 0.75 to determine this root correct to 2 decimal places. Give result of each iteration correct to 4 decimal places. Okay, so x1 equals 0.75. In the calculator, you're going to press 0.75 and then press equals to sign so that the answer key stores this value 0.75. Okay. For x2, you're going to write this sine inverse 2 upon 0.75 plus 2. But in your calculator, you're going to enter this. Let me do this on the side. In the calculator, you'll enter this sine inverse 2 upon answer plus 2. Because we need this answer value to change with every iteration. So when we do that fraction, I make sure the calculator is set in radians, shift sign, fraction 2 upon answer plus 2, bracket close, and press equals to, that will give you the result of the first iteration, 46 point something. Like, why am I getting a weird value? Hold on, let me try this again. Oh, because my calculator is in degrees. Oops. Okay, so 0.75 equals, that has stored 0.75 in the answer. Then shift sign, fraction 2 upon answer plus 2, bracket close. Now gives me the right value 0.81434. Need to go till 4 decimal places. Wait, 0.8143. Okay. For the next one, x3, you just press equals to now, and that gives 0.7904. Next, equals to again 0.7991. You keep doing this till the answers stop changing. 0.7959, 0.7971, 0.7967, 0.7968, 0.7968, 0.7968. Okay, it has stopped changing. Just to be sure, press equals to a few more times and still we're stuck at 0.7968. So the final root is going to be correct to two decimal places, 0.80.